Welcome. Today, our new chapter is function. First of all, I discuss very few properties and definitions of function. Very simple definitions. As you know, even function. Even function is, suppose fx is a function, if fx is equal to f of minus x, then this function is called even function. So, for example, cos x, sec x, they are even function in trigonometry. And in algebraic function, if a function contains only even power of x, then it is a even function, like say 1 plus x square minus x to the power 4 divided by x to the power 6 minus x to the power 2. They contain all even powers, so it is a even function of x. Similarly, for odd function, if a function be such that if fx is equal to minus f of minus x, then it is called an odd function. In trigonometry, sine function, tan function, obviously cosec function, cot function, they are odd function because they will satisfy this property. Fx is equal to minus of f minus x. In algebra, that is in algebraic function, if a function be such that all powers of x in the function is odd power, then it is an odd function, like say x minus x cubed plus x to the power 7 by x to the power 5. All are odd powers, 1, 3, 7, 5, etc. So it is an odd function of x. Next, periodic function. If a function be such that fx is equal to f of x plus t for least value of t, then it is called a periodic function and its period is that t. For example, sin x, cos x, all trigonometric functions are periodic. Sin x, cos x, tan x, etc. And we know that sine of x plus 2 pi, this is equal to sin x. So it is of that type, sine of function x plus t is equal to fx. So it is a periodic function and of period 2 pi. Just mentioning I am, the sine of x plus 4 pi, it is again sine x. Then it is periodic, but what is period? Period will be least between this, etc. This is least, so period is 2 pi. For sine function, cos function, period is 2 pi. For tan function, period is pi. Even sine of ax plus b, this is trigonometric function, it is periodic, and its period is 2 pi by a. And because sine function is periodic of period 2 pi, so its period will be 2 pi divided by coefficient of x here. It is immaterial, it is independent of that constant. That is like, say, sine of 7x plus 12. It is periodic function because sine function is periodic. Its period is 2 pi by 7. That's 7, and so on. The period of this function fx is equal to, say, x minus integral part of x. This is known as decimal part of x. From x, its integer is subtracted, so thing left is its decimal part. This is that. So it is a periodic function and its period is 1. Because you see, if x is equal to that, then f of x plus 1, it is equal to, we have to replace x by x plus 1, x plus 1 minus box of x plus 1 is equal to x plus 1 minus box x minus 1. Box 1 means 1. So that one, this one and that one cancels. So x minus box x, it is equal to decimal part of x. The domain of definition of a function. Domain of definition of a function means, suppose fx is any function. For all allowable values of x, all admissible value of x, if the function, least value of the function is a and greatest value of the function, the domain of definition means, actually it is, for all allowable value of x, if the function is real and finite, then these allowable value of x, collection of these, is called domain of definition. For example, say, suppose fx is equal to root over of 2x minus 3. So this function, for this function, it would be real provided 2x minus 3, which is under root, if this is positive or equal to 0. So if 2x minus 3 is greater than or even equal to 0, then this is positive and root over a positive quantity is real. So x greater than or equal to 3 by 2 is the domain of definition of the function, and we can write it like that: 3 by 2 less than infinity, or we can write like this: 3 by 2 infinity. First bracket means it is less than, this is less than, not equal to, and third bracket means it is greater than, even equal to. So this is domain of definition of that. For log function, say log of 4 into x minus 1, this will be any log. So this is finite and real if argument of that is x minus 1 should be positive. That is, if x is greater than 1, this is domain of definition of the function. So next, range of a function. Suppose fx is a function and within its domain, if least value of least value of the function is a and greatest value of the function is b, then this is a range of the function. Means the range where the functional value lies within this and that. So about mapping, I think you know mapping. Map 1-1 mapping is normally called injective or injection 1-1, and onto mapping is called surjective, and 1-1 and onto mapping is called bijective. Acha, about period of a function, it is of that about that I missed one point. Suppose fx is equal to f1x plus f2x. This is a function, and both f1x and f2x are periodic. Then period of the whole function is, suppose its period is t1, its period is t2, then period of fx is LCM of t1 and t2. LCM of t1 and t2. Like say fx is equal to sine of 2x plus cos of x. Both periodic. Its function, it is sine function, its function is 2 pi by a coefficient of x, that is 2, and its function is 2 pi, its period is 2 pi. So pi and 2 pi, its LCM is 2 pi. One important thing, suppose p by q and r by s are two fractions. What would be the LCM? What would be the LCM of this and that? LCM of this and that is LCM of P and R by HCF of their denominators Q and R, Q and S. So, I mean, PD actually this is equal to what I mean, the LCM of the numbers this and that is LCM of the numerators and HCF of denominators. For example, say 8 by 5 is a number fraction and another one is 12 by 10, another fraction. LCM of this is LCM of 8 and 12 by HCF of 5 and 10. LCM of 8 and 12, very easily you can calculate, it is equal to 24. And HCF of 5 and 10 is 5. So, LCM of this and that is this. This. Alright. Now, we take few problems for solution. The first problem is the domain of definition of the function fx is equal to cos of log of 2 minus x divided by root over of 9 minus x square is options minus 3 less than or equal to x less than or equal to 3, 2 less than x less than 3, minus 3 less than x less than 2, 2 less than x less than 3. We have to find domain of definition of this function, means the values of x for which the function is defined. Defined means it must be real and it must be finite. Now basically this is a cos function. So cos of any angle is defined. Cos of any angle is finite and real. So we have to find the values of x for which log of 2 minus x by root over of 9 minus x square is real and finite. So for finite, actually log of this thing, it must be positive and real. Must be positive means it is positive, and it is 2 minus x is positive means x is less than 2, and this is to be real, it should be 9 minus x square is positive, not even 0. If it is 0, so this thing is undefined. That is x square is less than 9. That is minus 3 less than x less than 3. So we get two things. Number one, x must be less than 2. Number one, and number two, x must be this and that. So we have to find the common value. It is common value between this and that is minus 3 less than x and less than 2. If it is more than 2, this will be real, but that one is not positive. So our answer is this, minus 3 less than x less than 2. So this option is correct. Next, find the domain of definition of fx is equal to root over of 2x minus 3 plus sin x plus 1 by root over of x minus 1. We have to find the domain of definition, and options are minus 3 by 2 less than or equal to x less than infinity, 3 by 2 less than x less than infinity, 2 is less than x less than infinity, 1 is less than x less than 3 by 2. So actually the function have 3 parts, 1, 2 and 3. One by one we have to find domain of that part, domain of this part, domain of that part, and after that we have to collect the common values of the domain of definition of these 3 parts. For this one, it is under root. So it would be real, it should be real for that purpose. It is actually 2x minus 3 is greater than or even 0, then root 0 is 0 defined. That is, x is greater than or equal to 3 by 2. Number for this one. Sin x. Next part is sin x. Sin x, actually, it is defined for all values of x. So for this, x is all value of x, all value of x. And this one is in 1 by root over of x minus 1. Root is there and denominator is there. Denominator cannot be 0. If denominator is 0, then it is undefined, infinity. And for it is within root, so x minus 1 should be greater than 0, not equal to 0. So x is greater than 1. So that we have to take common value of this and that. X should be greater than 3 by 2, all value, and x is greater than 1. So between this and that, the common value is x is greater than 3 by 2. So x is greater than 3 by 2 is the domain of definition of the function, given function. Now it can be written as 3 by 2 less than or equal to x less than infinity. Or this can be written as 3 by 2 comma infinity. This is within first bracket. Next. Domain of definition of the function fx is equal to 32 minus x c 3x minus 4. C stands for combination or option. First option is 3, 4, 5. Within second bracket means that set. Second option is 2, 3, 4, 5, 6, 7, 8, 9. Third option is 4, 5, 6. Next one is 3 to 8. Yes. And the problem is fx is a function of that type 32 minus x c, that its domain of definition we have to find. Now we know that from algebra NCR properties n and r both are integers, positive integers. Number one, positive integer means n is greater than or equal to 0, r is greater than or equal to 0, and both are integer, and n is greater than or equal to r. Because 6c6 it is possible, but 6c8 it is not possible. Now one by one we treat it. Number one is NCR. So we get n is positive, that is 32 minus x is positive. That is x is less than or equal to 32. Number one. Number two, this is positive. 3x minus 4 is positive. That is x is greater than or equal to 4 by 3. That is, it is greater than or equal to 2 because x cannot be fraction. It is 1 point something. So it is 2 or more than 2. And thirdly, this is greater than that. That is, we must have 32 minus x is greater than 3x minus 4. That is 36 is greater than or equal to 36 is greater than or equal to 4x. That is, x is less than or equal to 9. Now we have to combine all these things. Number one, it is first one is this: x should be less than 32, less than or equal to 32. Number two, x should be greater than or equal to 2. And number three, x is less than or equal to 9. And x must be integer. So it is list is this. So 2, 3 is possible, satisfying all these three. 2, 3, 4, 5, 6, 7, 8, 9. We have to stop there because x should be less than or equal to 9. So these are possible. So this is correct option. So option B, 2 to 9, this is correct option. Next, problem is find domain of definition of log base 2, log base 4, log base 8 of x plus 2. Find the domain of definition of the function fx is equal to that. Means we have to find the values of x for which the function is defined. Means for which the function is finite and real. Options: 2 less than x less than infinity, minus 2 less than x less than infinity. Number 3, 6 less than x less than infinity. And number 4 is 64 less than x less than infinity. It means value of x should be greater than 64 and finite. So it is basically a log function. Basically log function bases are different. So log of, say, base e x, this function is defined if x is positive quantity. That is, if x is greater than 0 for whatever be the base. Here, basically log function, its base is 2 and fx is that. So we must have log base 4, log base 8, x plus 2 is positive. This is basically log function. So its argument, this one, should be positive. Now, from this, we can very easily find that this is log of base 8 x plus 2 should be greater than 4 to the power 0. 4 to the power 0, property of log 1. That is log of x plus 2 base 8 is greater than 1. Now from this, it is log x plus 2 base 8. That is, x plus 2 is greater than 8 to the power 1. That is 8. That is, x is greater than 6. That is, x is greater than 6 to infinity. Probably the domain of definition is 6, x greater than 6, less than infinity. So this one. And this can be written as 6 to infinity. It is greater than, not equal to, both are open interval. The option may be like that, but in this case, this is the correct option. Next. The period of the function fx to sine of 8x plus tan of 2x is options pi, 2 pi, pi by 2, pi by 4. This function have two parts. Both are trigonometric functions, so both are periodic. So we have to find period of this and period of that. The constant 2, it is immaterial. So of that part, its period is sine function, that is 2 pi, and by 8 coefficient of x, and it is tan function, its period is pi by 2, so that pi by 4 comma pi by 2, and our answer is LCM of this and that. Both are fraction, so its LCM, that is period, is LCM of this and that, means LCM of between LCM of pi and pi, which is pi, and HCF of 4 and 2, which is 2. So answer is pi by 2. This option is correct. Next problem. The period of the function fx is equal to 3 sin x plus 2 mod of cos x. Option pi by 2, pi, 2 pi, and 4 pi. This is once again, it has two parts. This part is periodic, that part is periodic. Actually, the constants with periodic function is immaterial. Same is the case for here also. Period of that part is 2 pi. Sin x, simply sin x, its period is 2 pi. And this is, it is 2 pi. 3 sin x and 2 cos x. Okay. And period of mod cos x. Period of cos x is 2 pi. But period of mod cos x, it is pi. Because if fx is equal to mod of sin x or cos x, so say cos x, f of x plus pi is equal to mod of cos of pi plus x. It is equal to minus cos x. It is equal to mod cos x. So mod of sin x, function sin x and cos x is both, period is pi. So its period is again pi. Now actual answer is LCM of this and that. So which is equal to 2 pi. So this one is correct option, 2 pi. One important thing I tell you, mod of sin x plus mod of cos x, its period is pi by 2. Try to remember it. You have to remember it. Period of this and that, both mod sin x plus mod cos x is equal to pi by 2. Because if we take fx is equal to that, f of pi by 2 plus x will be equal to mod of sine of pi by 2 plus x plus mod of cos of pi by 2 plus x. Its value is mod cos x. Its value is mod, this second quadrant, so cos will be negative, mod of minus sin x, but mod minus sin and mod sin same, so it is equal to sin x plus cos x. So its period is pi by 2 because it is fx. Fx is equal to f of x plus pi by 2. So its period is pi by 2. This is very important. You have to keep in mind. Okay. So next day we will solve few more problems. So before that, I tell you to share. If you feel that this is helpful for you, please share it, like it, and subscribe it. Thank you.